A very good day to my panel and welcome to my video presentation for my FYP. My name is Binti and allow me to introduce my supervisor, Ms. Sumaiya Binti Mashori. For my FYP, my title is Recycle to Reward System using Programmable Logic Control, PLC and Raspberry Pi, which is as known as R2R system. And this is my poster. Now I'm going to explain my poster. And this is my headline. As you can see, this is my name, my supervisor, and I'm from JTKE, Faculty of Engineering Technology, and this is my titles. Now I'm going to explain my abstract. In this project is to develop a recycle to reward system as well as R2R system using PLC, Programmable Logic Control, and Raspberry Pi. The system will convert the weight of the bottles and tins into points, and then the user can use the point to exchange daily supplies or maybe food supplies as well. And for the operation of this system, when a RFID, or also known as radio frequency identification card, is read and an object is inserted, the sensor will detect the material of the object and send the signal to the Raspberry Pi. The servo motors will send the objects to the storage bin, and also it will based on the material of the weight and the weight of the object to convert it into reward points. The object will be rejected if the weight of the object is not within the preset range of the system. The user will be able to see their reward point from the LCD, and also furthermore, an email system is added to the system which will notify the owner when the storage bin is full by using the infrared sensor. Now, I'm going to explain about the introduction. For the first one, Worldwide Fund for Nature stated that Malaysia has become the largest plastic consumer and worst ocean Pacific polluters in Asia, which consume 16.8 plastic per person compared to China, Indonesia, Philippines, Vietnam, Thailand in 2020. SW Corp, as known as Solid Waste Management and Public Cleanliness Corporation, stated that 40% of the total waste, there are 13.2 plastic waste, and the Malaysia recycling rate is only 28, which is very far away compared to Germany, which is 66.1. Therefore, this project is to develop to increase the awareness of Malaysia to recycle and also increase the recycling rate of Malaysia. And for the objective is to design a R2R system for 355 500 size milliliter size plastic bottles and 220, 220, 240, 320, 325 size tin. To program the sensor as input and motor as outputs depending on the condition of the inputs, and to develop coding for RFID system and create a database, program reading scale, and set the range of material by using Raspberry Pi. As for my literature review, I have researched a few of research paper, and I found out that most of them are using inductive proximity sensor. As you can see, this blue color sensor is the inductive proximity sensor to detect metal, and also using infrared photoelectric switch sensor to detect plastic. Some of them might recommend for the capacitive proximity sensor, but after I done a few research, I found out that infrared photoelectric switch sensor is more suitable for transparent PET bottles. And also for the weight, I'm using 1 kilo load cell to detect the weight of the object. And also the servo are using for movement and LCD to display the information. And for the methodology, in my project flowchart, as you can see in here, I have 6 parts. The first part will be the user card ID, and second one, invalid object rejection, void sensor and material detection, email feedback, storage detection and rejection, and also object sorting. The first one, user have to touch their card, and if the card is registered in my SQL database in the system, it will display the information, and it will continue to detect the object, weight, and also the material. And then if it's invalid, it will directly reject. If it's valid, and it will detect about the storage, is it full? If the storage is full, it will send an email feedback to the owner. But if it's not, then it will proceed to the object sorting and also convert the point to the user and update in the database as well. This is the block diagram for my R2R system. As you can see, this is the controller, and these are the 3 LED which is indicator lamp for inductive proximity sensor and also photoelectric switch as well. And the red one is for the emergency button. And I'm using start button and reset button for this on-off push button. And I'm using the servo motor connected to the holder, as I call it as holder servo. As you can see, it's placed under here, which allows to push the object. And here are the both sensors at here, and this circle one is the load cell. And here will be the LCD and RFID card reader and also Raspberry Pi. The another sorting servo is right over here, as you can see, the black color, and attached to the slide. And now this is a PLC ladder diagram. And now I'm going to present a 6-minute video which I recorded to demonstrate the process of my project.
A very good day to my panel. My name is Guan. Today I'm going to present my final year project, which is Recycle to Reward System. Allow me to introduce the controller that I use for this project. Firstly, I'm using PLC OMROM CP1E as my first controller, and then the second one is Raspberry Pi. And now at here, I have an emergency button, which if I press it, it will shows the LED red is on. If I release it, it will turn off. And then I'm able to turn on the green light and start the system. If I press red, it will cut off all the electricity. Okay. As for now, the red button, this one is for a reset button. And I'm connected the PLC to the Raspberry Pi by using relay. This is a 24-volt DC relay. And allow me to introduce my sensor. I'm using load cell to detect the weight of the object, and the infrared photoelectric electric switch, and also the inductive proximity sensor. The infrared photoelectric switch is for the plastic, and also the inductive proximity sensor is for the metal. And here is the card reader, and here is the infrared sensor which I use to detect the level of the storage. And here I'm using the first servo is for the holder servo, and the second servo right over here is for the slide. And now, as you can see, the LCD screen is showing scanning. And now I'm going to use a random card to scan, which will show the username is user3 and the point will be 654. And now I'm using this bottle, for example, and I'm placing it in it. As you can see, the infrared photoelectric switch is on, and also the green LED lamp represents the photoelectric switch as well. After that, it will ask press enter after placing weight, and by pressing enter, the system will show like this. You will set the bottle, send it to this part, and then it will show the plastic detected, and the new point will be 810. As you can see from my screen here, it also updated how many weights is it? It's 26 weight, and the point is 810. And the system will ask, do you want to continue processing again? I will press yes. And now I'm going to show you this. For example, I'm using this hydroplastic for my sample as well. As you can see, now both sensors are on, and then it will show the true LED green light is on. And now I will place enter again for this, and the system will start kicking the metal tip to this, and it will show the metal detected new point 906. And here is it. Here is the weight. It is 8 grams, and also the total point will be 906.
And what happens if the storage is full?
And now I'm going to show you about my full storage system, which is email system as well. For example, I'm using this plastic bottle again, and I'm putting in it, and then this 2 infrared sensor, I'm using it as a full beam sensor. When it is full, it will detect it. As you can see, inside the lamp is on, and the system will ask, do you still want to continue again? I will press yes, and then it will ask, press enter after placing the weight. As you can see, I'm still blocking it, and then the storage will reject. send the bottle to this reject bin. This is because the storage is full.
And this is the email system. When the storage is full, the system will send an email to my Gmail.
And also, after this, inside my email, and the time now is 3:33 in the afternoon. As you can see, I can receive one email from R2R system 001, and it shows R2R plastic is full, and 3:33, which is it will send the email immediately to the owner. Here is the content.
And what if some user fill the bottle with water?
Now some people may ask, what happens if the user fill the bottle with some water? For example, as this bottle is filled with water, as you can see, there's some water in it. And I will use this tag to scan to show you that this is my username and also my point. Now I'm inserting this bottle in it, which is still detected by the photoelectric switch. As you can see, the indicator lamp is still on. And then, after this, I will press enter. As you can see, it will start push the bottle, slide it down to reject bin. This is what happened because the bottle weight is 56, which is overweight, which the system said is below 40. So the bottle will get rejected.
And now I'm going to explain my result and discussion. As from my result, I'm using the forward rate, which is the plastic will 3 points per gram and the metal will be 6 points per gram. And the formula I've used is the new point equals to the weight of object and times the convert rate, and then it will plus the original point and convert back to the new point, as you can see inside the video. And now, for example, I'm using an aluminum tin and I tried it 5 times. The aluminum tin weight is in between 13 to 12.9. As you can see, that is almost like 0.5 error grams only in my system, which can be considered as very stable and also valid. And this is actions that will be taken by the system when the metal is below and also the plastic is below by 40. It will show the sorting servo angles and also the holder servo's angles. And if the metal or the plastic is more than 40, it will start to reject it. And also for the glass, it will also more than 40 and it will be rejected. You might ask that why I didn't use glass for this system. This is because that there is a height between the slide and also the storage bin, which may have the probability that the glass will be broken, which is danger, and also it cannot be recyclable anymore. And now this is my dimension for my system. The height of the system is 100 cm and the width is 60 cm, and for the storage bin is 30 cm times 30 and times 30. And for the conclusion, in the conclusion, the project able to complete the objective, differentiate materials of deposit objects, store user ID and update points based on weight of objects to the database. Both controllers, Raspberry Pi and Omron CP1E are able to function well and complete the task programmed by the Python programming. As you can see, this is my reference. The reference are just a part of it only compared to my reports. If you want to refer more, you can read through my reports as well. And thank you for watching. These are my photos with my FOP projects. And for those YouTube watchers, please subscribe and like my channel. Thank you very much and have a nice day.